Hey everyone, welcome to part 6 of this 3D object detection tutorial. In this part we're going to learn how to make this bird's eye view of our detected scene right here, and then we're going to learn how to wrap everything up together in a single frame and make a video. So let's get started. So after our sanity check right here, where we found out how everything is displayed in the real environment, we found out that everything is looking okay, we might want to package everything up into a nice video. So in this video right here, we're gonna basically stack up frames that have the detections in the top, point clouds in the bottom, and the bird's eye view to the right. And here's a sample of it, just so you can see what we're gonna make. So right here you can see it's pretty jumpy and spotty, and you'll notice that as we have things like this bus right here that cause huge occlusions. As soon as we pass this bus, we get more detections back, but we could actually solve a lot of these issues by using a tracker, by using Hungarian matching and a Kalman filter, which we can find that in a future tutorial. But let's go ahead and find out how to make this canvas right here. So to do this, we're going to have a set height and width, and we're going to keep the ego vehicle at the same spot this entire time. So here's the center, and here's the X, Y, and Z coordinates for the draw rectangle function from CV2. So the ego vehicle is just going to stay right here the entire time. And now I have this helper function called draw scenario that's going to make everything easier. So right here we have our blank canvas right here, and we have our IMU XYZ detection locations. And this scale factor right here is basically going to give us like a little bit of spread to make everything look nicer on our canvas. So first thing we do, we draw the ego vehicle, goes in the same spot every time. And then right here, we're going to draw our detected objects. So what we're doing right here is we're grabbing the center in pixels. So we're going to use our scale factor to get our X and or Y and X coordinates right here that go to our ego center coordinates. And then we're going to simply get our X, Y coordinates for the ego center location, so the top and the bottom of the rectangle, and we're simply just going to draw those straight on the canvas. And right here we have a little example usage right here. So we make an array of zeros. We use depth 3 because we're going to also put these together with RGB images, and we want to keep everything consistent. And we also use a D type of UN8. So when we make our video later, opencv will have an array with consistent UN8. So right here we simply just call draw scenario our detections from our most recent run from the last video, and we get this canvas right here. So, and now we could use the simple hstacks function to put all these together, and you'll notice that we have this line right here. So I added a line of width 1 just to make this look nicer, and I also made sure to make this 3 channels and set it as UN8 to make it consistent with all of our other frames that we're stacking together. So to make our video, we're going to need to get the frame rate. So we're going to get the frame rate from the camera updates. So I've made this two helper functions right here. One is get total seconds. If we have a vector of hours, minutes, and seconds, we can simply multiply the hours by 60 times 60, which gives us the seconds, the minutes by 60, which gives us seconds, then we add the seconds. We add everything together, we get the total seconds for an hours, minutes, seconds timestamp. And then this right here, timestamps to seconds, we read in our CSV. I have some split function right here. It basically gives us the values we need. And then I take the hours, minutes, and seconds, put them all in a single vector, and then I map this function up here to this vector, and we will get total seconds for the entire frame. So let me run this, and then I'll also print this right here just so you can see what this thing functions outputting. So right here, so basically we just get a huge array with total seconds. So I don't know why that's taking so long. So bam, right here. So I'll do just the first 5. So you can see the first 5 timestamps. I don't know why it doesn't do float, but you see this first one is a float, and we'll do the second one. So you can see it's about a tenth of a second after. So what we're going to do to get the frame rate is we're just going to take the diff of this whole vector right here, and that's going to give us the time between frames. And we're just going to take the median time between frames. We could use mean. I prefer to use median. And we're going to go one divided by that. So we have the basically the seconds between frames, but we want to get frames per second, or the hertz. So we just divide by that, and we end up getting about 9.65 frames per second. So that's pretty close to what we saw earlier with about 10th of a second between frames. So we're going to use this value cam to FPS to make our video later. So wrapping this all up, we want to iterate through every single image that we get. And we've already seen earlier that our images, LiDAR points, and GPS frames are all the same length. So we're just going to take the length of the left image paths, read in our left image as with CV2, take in our bin path. So this is just the path to the binary. Read in our GPS frame right here. We have this getAux function that's in the kitty helpers. And then we're going to get our detections and our LiDAR UVZ, basically LiDAR projected onto the image. We're going to get our transformed bounding boxes and just the coordinates right here. And we're also going to get our XYZ locations relative to IMU of all the detected objects. And then we're going to draw our velo coordinates on our blank image. So basically project the LiDAR to our blank image. And now we're going to stack our images. So we're getting the left image with all our detections and depths. And we're getting our LiDAR projected onto the image. So basically these two things right here. Now we just need to make the bird's eye view. So we go get our empty canvas with our known width and height. And we make it 3 channels. And then we draw each object on it. And we already have a static portion, remember, in our get canvas function that's always going to draw the ego vehicle where we want it. And we just leave that in there for convenience. Then we stack everything up together. We append it to a list. And then we can go down here and use a CV2 video writer object. We have our save path, our encoding right here. I'm using divx, but there's a lot of other options. And the encoding also goes with the extension right here. So if you use this divx, you more than likely need to choose a .avi. And then our frame rate right here. And then we also need to pass in our width and height. So right here, I take the frame shape right here, and I get our height and width from our most recent frame that we're using. And then simply iterate over all the frames that we've appended to this result video list, and use this CV2 writer object out to write every frame to it. And then we make sure to switch from color back to from BGR to RGB, just to make sure that the CV2 has the colors correct. And you can see here's the final frame right here. So that's everything for this. Hope you enjoyed the tutorial. I hope you learned a lot. I'll see you in the next one.